Welcome to our class today as we continue with our series of lessons on deployment, verification, and interaction of ZK verifiers on Sepolia. Earlier on, we had looked at how to deploy, verify, and interact with ZK verifiers on Sepolia using Foundry. Then after that, we looked at how to fund Sepolia with free ETH. Now we use that to do deployment, verification, and interaction. So our goal today is just to build a reproducible, secure pipeline from Noir circuit to on-chain verification of on-base Sepolia. So I'll be taking you through, first of all, how to write Noir circuit. Of course, ZK, generating a ZK proof, generating verifier.sol, and then deploying. I'll also remind you how to acquire. If you do not have an account on MetaMask, I'll take you through how to get an account. I'll be taking you through how to use Foundry, and of course, if you don't have it, you need to install it. Noir, proof generation, and then verification on Basecamp. So I'll also be taking you through that. And of course, as we've always said, these lessons or this series of lessons are important to developers and anybody with the basic Solidity experience would also benefit from this. So our objectives, we expect that by the end of this lesson, we should be able to, first of all, add Sepolia to MetaMask because it's not it may not be there by default. So if it's not there, you may want to add it. And so I'll be taking through the steps of doing that. Just a reminder, because we had already done that in our previous lesson. And then after adding Sepolia to MetaMask, I then take you through the process of obtaining test ETH, free ETH, because we'll not be using our real ETH, we'll be using test ETH, free ETH, because we are doing just on testnet. But if you want to proceed to mainnet, then you may want to use your real ETH. So in the process of doing this, I'll also be taking you through how to use faucet or bridge constraints. And then after that, I'll show you how to configure RPC endpoints. Remember, we'll be required to have the RPC key. So I'll be taking you through the process of acquiring it. And the RPC URL. So I'll be taking through the process of acquiring that URL. Then also for purposes of verification of our deployed contracts, I'll be taking through how to create and manage Basecamp API key. And this is what we'll be using for source verification, just verifying that whatever the source documents you have are same as those are deployed. Installing and using Foundry that we'll be using to deploy and verify contracts. I'll also be taking you through that process, how to install. Then generate Noir proofs. After generating, we format them for on-chain submission and call the verifier via CLI or Explorer. If there are any issues, common issues, I'll be showing you how to troubleshoot and following best security practices or security best practices. So those are the objectives of this lesson that by the end of this lesson, you need to have understood those 7. Then just before we proceed with our lesson, we are required to have the following. 1, you are required to have MetaMask installed and funded with the free ETH. And of course, that is one thing that I'll be showing you. You just need to have it installed, and then I take you through the process of funding it. We're supposed to have a terminal. I'll be using WSL. You may want to have WSL and VS Code or any other. I'll be using VS Code for writing of my code. Local repo with Foundry structure. So you can just, of course, you can clone mine, which I've already shared in my notes, my communication on Twitter and LinkedIn. I already shared the link for my repo that I'm using to teach this lesson. So you need it. You need to have it because we'll not go through all the processes of coming up with that, because that is something we'd already done. So we had already, you can even use any other. You can use any other repo because where we getting new codes, I'd be taking you through that process. But we already have the rest. Now we've done a lot of code writing, ZK proofs, and now ZK proofs. Done a lot of that. And if you were to just use any of them, it would be better because anything new that we had not done before, I'd be taking you through that. But what we had done earlier remains. So we just require one example, one code, one project, and then we proceed with it to deploy the contract. Once you have, we know how to generate a proof, we know how to generate Solidity verifier. So if you have those, then it's easier for us to proceed from there, because our interest is just how do we deploy? How do we then verify? Those are our interests. Now, part of what we'll be using are here. Our network will be based Sepolia. This is already using testnet, and its chain ID is 84532. We've seen how chain ID is used in our .env in our previous lessons. Then our public RPC is this. Then we have the Explorer. If you wanted to, of course, we may also require base mainnet. Remember in our last class, we said we have the default base mainnet, but there's a slight difference. What it has as its public RPC, it does not communicate with our base Sepolia correctly. So what we did on a previous lesson, we did change it to this. The default one that comes with the base mainnet, we changed it to have this, because this is the correct one. Now, so first of all, we begin with how do we fund our base Sepolia with free ETH, because we require this free ETH for deployment, verification, and so on. How do we fund it? So then what we require, our steps here is, once you have MetaMask, you go to settings. So this is a process of adding base Sepolia. So first of all, I want us to add base Sepolia to MetaMask. So the process of doing that, you go to MetaMask, settings, networks, then add network. Then under add network, as if base, for me, I already have base Sepolia, but if you don't have it, you would fill this. These are what you'll be asked to fill. So I just want to take you there, that you see what I'm talking about. So we go to our browser. Now, while here, my MetaMask is just an extension here. It's an extension here, and I think you can see it. So can even extend it. Let me move this on the other side. Now, this is MetaMask. So we go to settings, networks, then add network. Now the networks are here. These are the networks. You can see the default one here is Ethereum mainnet. This is the one we have as a default. Mine, the Sepolia, I added it, is here. What I'm saying is, if I did not have it, because I'm just seeing that the format I've given is slightly different from what mine has. So I would click here. When you come down here, there's an option for, because these are the networks, these are popular networks. And now, since there's no option for adding, I come to custom. So I want to customize, come up with my own network. I click on add custom network. So if you do not have the Sepolia, you would add here. You just fill this, and I'd already given you what you are going to fill here in these spaces, blank spaces. So you just fill it, then save. Then at the end of it, you'll be having Sepolia. That is what you do. So where we have network name, you would be writing Sepolia. Where there is RPC URL, you'll be writing HTTPS and so on. Where there's a chain ID, writing 84, 532, currency is ETH, and then block explorer, you write this. Then save and switch network. So that's how you get the Sepolia on your MetaMask if it's not there, because we require it there, because that is why we want to deploy our contract to. And then after deployment, we will have to verify and interact with it. So you require it added to your networks. After adding it, we will want to fund it with the free ETH. That will be our next step. So get Sepolia test ETH from faucet. So we are getting our free ETH from Sepolia ETH. We are getting Sepolia ETH, not the Ethereum Sepolia ETH. Remember, in our previous class, we also used the Ethereum Sepolia ETH, but this is now different. This is Sepolia. Now, these are the common faucets where we can get from. You can get it from Alchemy faucet, you can get it from PK910 faucet, or you can get it from QuickNode faucet. But previously, we've been working with the Alchemy faucet. So when you click on this link, it takes you there. This link is not common, is not full, because my page here is not, there's a part that is outside my page. Let me just see if I can get complete code and share it with you. In fact, what I'll do, I'll take you to browser and then use the complete code there, that you can see where we're going to. So this is the entire link. I don't know if you can see it. Let me just move this one down. www.alchemy.com / or is it / faucets, then another / Sepolia. So when I click enter, this is what I get. This is what I get. It says, to prevent bots and abuse, this faucet requires a minimum base mainnet balance of 0.001 ETH on the wallet address being used. So what this means is that we've just created Sepolia, but we have base mainnet. And that base mainnet should have at least 0.001 ETH. That means if you do not have this ETH in base mainnet, and then you try and have it. Supposing you have it in a different account, remember that this is a new account we've just created to ensure that we're not exporting or exposing the private key to the public. So we created a new account without ETH. So maybe we may assume you have another account that has ETH and you want to transfer to this, because it must have 0.001 ETH. So if it has that, then you would paste here the address of your, let me just show you what the address is. Going back to MetaMask, this is my MetaMask. Click on it. And this is my address here. I can copy it. You can see address copied. You can copy this address. After copying the address, you click it here. And then click I'm not a robot. And then you send me it will go, you'll get 0.1 base Sepolia. It's written here fast and reliable. 0.1 base Sepolia ETH under 72 hours. Okay, 72 hours is written here, but it's almost immediate. Because when I did it, I found mine immediately. You only need to ensure that your base mainnet has 0.001 ETH, first of all, before you ask for send me ETH. And that's what I've written here, and I've said some faucets check base mainnet balance. If you see a denial, bridge a small amount to base mainnet. And that is what I want to take us through. How do you ensure that base mainnet RPC is correct? Now, before you bridge, I had already talked of the base mainnet that automatically comes to our network has some incorrect RPC. So we begin by changing that. When you click on edit, you find that the RPC that is there is different from what I had recommended at the beginning of this lesson. So I've said here, MetaMask auto uses Wallet Connect RPC for base mainnet, and this causes bridge or faucet checks to fail. So to fix this, you go to MetaMask, then go to settings, go to networks, base, and then edit. And then at that point, you go to the RPC URL and change it to this. Of course, you'll get it something different from this. So you just change it to this. Mine is already changed to this, but I'll just take you through the steps. Just take you through the steps. So once again, we go to our MetaMask. So this is my MetaMask here. Under MetaMask, just move this on the other side. Oh, there's a network here. So I'll come to base. Mine have already even edited to base mainnet. Yours could be reading base. So when you click on base, not click on base. Just come back. Yes, base is here. On these three arrows, on these three dots, not arrows, three dots, you can see edit. When I click on the three dots, let me just come back, dots, three dots, there's edit. So there you can see it gives you space to write the name. So this is why I edited mine to base mainnet, but it was base initially. Now look what this RPC URL, this is what I'm referring to. The yours could be different. Mine I've already edited. So you just click on add RPC URL and it gives you it allows you to edit. You can see the chain ID is already okay. Current symbol is already okay. And the block explorer URL is already okay. So the only place you'll be editing will be this. So by just clicking here, it allows you to edit and then save. Now, once you've done that, if you had it in a different account, you would transfer it here. You would transfer it to the account you want. Just showing you how to change networks and so on. So you would transfer it to this account if you're at 0.01 ETH elsewhere. So that is how you ensure that the base mainnet has the correct RPC URL. Now, once you confirm that, you would now want to ensure that it has 0.001 ETH. So that's why I'm saying here, bridge ETH to base mainnet. So to do that, you would use the official bridge to deposit a small amount of 0.001 ETH. So the steps are here. You would visit this https bridge.base.org, connect your MetaMask, and then from the Ethereum mainnet you choose that to base mainnet, enter the amount, click deposit, confirm the transactions on your MetaMask. Then wait for some few minutes to verify. You wait for some few minutes for the transaction to take place, and then you verify on the base scan. Now, maybe we go here and I show you how it works. Just a minute. So we want to visit bridge.base.org. So again, let's go to our browser. Let me stop sharing this. Go to our browser. This is the link, bridge.base.org. Now this is what we get, but I'm interested with the supported networks. We have the best mainnet and the best Sepolia, but we want best mainnet. Select token. What do you want to send? So you're just telling us how much, 0.001, for instance. You also want to receive isn't it? And to receive it. I don't know that I chose the right place. I'm wondering why it keeps on alternating. Just go back. Maybe we can try and send USDC. You find out how much of that would require, would make 0. And the chosen garden. Supposed to have chosen super bridge. We choose super bridge. I was on a different. I'll do that. Then you're asked to connect your wallet. Click on wallet. It's connecting. Now, I do not want to transfer, but you can see what I have in my wallet is less than what I can send. So this will not happen. So you need to have exactly more than what you will want to send. So that is what you need to do. You just follow the on-screen commands to achieve that. Now, so after transferring 0.01 ETH to your base mainnet, you may want to verify the balances just to be sure that the transfer has occurred. Then after that, go to the RPC to get the RPC URL. And you're using this to you get your. You can copy the entire thing, or you just copy your API key, then add it to this. You can also get the whole of it. You can get the whole. So you just go to https://sepolia.base.org. And you get your URL. But I'll come back to that to show you exactly how that is done later on. I'll come back to that. Now, once you've gotten your URL, you add it to your .env together with the private key, and then you test the connectivity. You test whether your connectivity is okay, and you are just running this command in your terminal. Now this is the expected result if the connectivity is accurate. But if it's not, then you may find some error. And if you get some error, it just means that check your URL and see whether it's correct. Verify the chain ID and see whether it's correct. And then switch to the provider RPC if rate is limited. So in case there's an error when you run this command in the terminal, then these are the things you're supposed to check and see whether they are accurate. Now the base scan API key is used for verification, and this is where you get it. You'll need to sign in, or that is if you have an account, you just sign in and get the API key. But if you don't have an account, you would create one, then go to the profiles, API key, create new, and so on. I'll take you to the browser just for this so that we look at it. Just a minute. So let's go to our browser. And here's the link. And for me, I already have an account. So if you have an account, you can just sign in. If you don't have an account, you would sign up. Just click here, sign up. Now, when you sign up, you'll be required to fill all this. And once you fill all this, create an account. And after that, you'll come back and sign in. Come back here and say sign in. By signing in, you choose a username and then your password. Once you put in your password, this is what you get to see. Now, so what happens when you click on API dashboard? This is what you get to see. Okay, so after that, what we wanted, of course, was just to create that account. That's what we wanted, but the API key is not found here. Let me find, there's a link that I was using to generate the API key. Just a minute. For the link for, you see, once you've generated, once you've signed up an account at this point, there's somewhere else you go now to get the API key. I'll take you back there. In the meantime, let's proceed. When we get to that link, we go back and find the API key. Now, once you have the API key together with together with the RPC URL and the private key that we're getting from MetaMask, we bring them to .env. This .env, remember we said that when you committing your repo to GitHub, you ensure it doesn't go with the rest of your project. It should remain as part of Git ignore. So there's a way we do it, and again, I'll be showing you. Of course, we looked at it last time also. But I look at how it looks like. This is what we require there. The RPC URL, the private key, and then your Etherscan API key that is used for verification. After you have it, you would run source space .env just to ensure that it's working. The security reminders here is what I've already mentioned, is that add .env to gitignore and use the CL secret for automation. Earlier on, I had showed you how to get the account from the MetaMask, but you also require the private key from MetaMask. Remember this private key, we are putting it inside .env, just to and again, that .env, we are putting it inside GTignore, ensuring that it goes to GTignore so that your private key is not exposed to the public. If it has, supposing it has your ETH, this is to prevent people from getting access to your ETH. Now, so how do we get our private key? I'm back to my MetaMask. These three lines, when you click on them, you have account details, and this is where I click. Under that, you have private key here. This private key, when you click on that, you are asked to insert or enter your password. So I can enter my password. Then confirm. After confirming, you're told that your private key provides full access to your wallet and funds. So do not share this with anyone. So MetaMask support will not request this. So they're just giving you some warning, but they tell you here that hold to reveal. So when you hold that, it reveals your private key. So I just stopped so that I do not expose my private key to the public, because that is what I had already asked you not to. So you just hold and then it opens private key, and then you copy that. So I'm supposing that we've already installed Foundry, because it's not the first time we are using it. We've used it before for proof generation and so on, verification. So we already have Foundry, but supposing you do not have it, then you would run this curl, this link. Then after running that, you would run Foundry, and this will install Foundry. You can check the version and even cast version if it's supported. But just check the version, there's no problem. But once Foundry runs, Foundry will install. But if the above commands fail, then you would need to ensure that your path contains Foundry binaries, usually home.foundry.bin. So ensure that it has Foundry binaries. Now, Foundry, I'm talking about recommended Foundry.toml. And why I'm referring to this is that at times you find that, not at times, but always, the verifier.sol generated by this process will be larger for deployment. And you know our goal is to deploy these contracts, but it's larger. So since it's larger, for us to be able to deploy it, you would introduce optimization settings. These optimization settings where optimizer equals to true, and then optimizer runs 200, and so on. So you just introduce these optimizer settings. This is to ensure that Solidity compiler version aligns with the contracts pragma. Now, so if your Foundry.toml is in that format, then it means you'll be able to deploy your contract. But without introducing those optimizer settings, it's not possible to deploy this. It will always bring you errors of bigger size, telling you that the size is larger than what can be deployed. Now, earlier on, I had said you can clone any repo that we've written in the past where we were generating a Solidity verifier. But again, it should have circuits, contract, script, JS. Script is inside contract. Then you have JS. So circuit is a folder. Circuits is a folder. Contract is another folder. JS is another folder. And these folders perform these roles. JS is for proof generation. As contract is what contains the Solidity verifier and then the Foundry. And this Solidity verifier is what we're going to deploy. Script, this one will just contain scripts. In this case, we'll be having deploy scripts, deploy.s.sol script. And then we have the circuits. This is what contains our SRS and main.nr. Now, to deploy a contract, there are two options. You may want to deploy it manually without using a script, or you want to deploy using a script. So if you want to deploy it without using a script, and I've already said that make sure that your Foundry.toml has the optimizer settings. So if that is the case, you would then run this command in your terminal. You're only replacing this part with your RPC URL and this part with your private key, and then this part with your Etherscan API key. The rest remain as they are. Just replace the ones I've pointed out. And I've stated here, you replace those ones. Now, if you do that, remember this code is doing several things. Apart from deployment, it's also verifying your contract on chain. So it's verifying. When you go there, you would find that the contract is verified. So it's doing all this deployment and then verification. Now that is one way of deploying without using a script. And the other way you may want to deploy is by use of script. So inside the script, you remember I said we have the contract folder, and inside this contract folder, we have the script. You recall the above structure that we just mentioned. So inside the script, you create a file called deploy.s.sol, and inside this file, you paste this command. This is what you are then be using to deploy this process, automating the process of deployment. And this is most preferred, especially if you are doing a deployment from time to time, most often. But if it's just once in a while, you can use the above command without this script. Now, if you have the script, then you'll go to your terminal and then run this command. But before that, replace your RPC URL with this, and then replace this with your private key, and then replace this with your Etherscan API. This command is just like the one used above. The only difference could be this first line. The other one did not have the script, but this one has. The rest is just the same as we saw in our previous command. So you run this in your terminal, and again, it's performing deployment and also doing verification on chain. Maybe I may just want to remind you how to generate proofs if you've forgotten, but this is a process we've done before. Like previously, when we did our proof generation, we used yarn generate proof. And apart from that, we also used a BB proof, which we already have that command. So if you have those commands, we've already generated the proof. We've already deployed our contract and verified it on chain using the above commands. So what follows is for us to build a circuit and run the prover, generate a proof for using the BB proof. Of course, I was assuming you already have it because these things we did earlier. You also, inside your target, apart from the proof, you would be having public outputs inside your target. So your target has the proof and public output, but the proof is in binary form. In other words, you cannot see it. Public inputs, in some cases, could be in binary, some cases could be in hexadecimal. But what we want to ensure that your proof and your public inputs are both in hexadecimal, so that we go with them on chain, paste them where we have read contract. Because when you go to the contract that we deployed, you would see a place says read, write. So we go to read, and what we want is paste our proof there, and then paste our public inputs in its respective space, and then query. So when you query, if the proof you pasted and the public inputs you pasted from your local machine, if they are the same with the ones you deployed, then it means that verification is complete. It means that verification is complete. Because what we're just doing there is to want and just be sure that what you deployed is exactly the same as what was on local machine. But before that, the ones that were on local machine, you make them hexa. So to make your proof hexa, given an example of how to convert the existing proof to hexa, and this is what we have. This is the command you run in your terminal. Inside target, because target is where your proof is. I had already explained these concepts in our earlier class, and I think they're very clear because we're just doing a recap of that. Now, that is if you want to verify on chain. So you go to your local machine, convert your proof, and convert your public inputs to hexa. copy them and paste them in areas requested for. On chain, go on chain, and the place they want you to paste your proof in hexa, the place they want you to paste your public inputs in hexa, and then query. That is one way. The other way is you may just want to verify locally without necessarily having to go on chain. And if that is what you want, you would run this command in your terminal inside contract. You're doing this inside contract, but you just want to change a few things. So this is a proof. You would copy your hexadecimal proof and replace this with that proof. Of course, it will be a very long thing, but just replace it with the entire proof in hexa. And then this is your public inputs in hexa. Copy it and paste it here. And then you replace your RPC here. Just replace. Then run this command inside your terminal, and you will see verification occurring. And if it's correct, it will tell you that this verification is true. So just confirming that what you deployed and what you had in your local machine is the same thing. If there are issues, this is how you debug those issues. Of course, the issue just confirm that your RPC returns block number via the ETH block number, and then confirm that if the chain ID matches the expected, recompile the identical compiler settings that are used for deployment and verification. Ensure that proof verification generation step completed without errors and so on. So these are some of the things you want to debug, supposing there were issues or errors. What are the best practices? I had already mentioned the issue of the private key not being exposed to public, and we are putting it in .env and preventing it from being committed to your repo, so it remains in GTignore. That is something we must not take lightly. And then use hardware wallets for production, avoiding exporting production key to disk. You can go through this, some of these security issues. Now, next step, we've looked at, we've looked at how to do fund your best Sepolia with the free ETH. Seen how to, after that, how to deploy, seen how to verify and then interact. But now our next steps is just to ensure that all these processes are automated using scripts. So they need to come up with the verify proof.s.sol. We only had deploy script. But we can also have verify script, verify proof.s.sol for verification, so that we're not doing it manually. We also may want to automate builds and dry run deploys in CL with encrypted secrets, and then build a front end to collect proofs from clients and submit them to the verifier. And then emit events, e.g. proof verified, address indexed, sender, and so on. to simplify UX and monitoring. So those are the next steps. And if you wanted to read more things on this subject, these are the resources you may want to refer to. These resources. Supposing there's an error you want to go deeper, then refer to this. Our summary is here of what we did. And then if you wanted to reach me, the contacts are also here. Thank you.